Hello, we're here to talk to you today about how predictive text relies on the use of stochastic matrices and other linear algebra functions. At the most basic level, online predictive text operates based on stochastic matrices, specifically on Markov chains that draw on previous information to make their predictions, such as most commonly used words. In some cases, such as your Google account, this data will be specified to your search history. The values in these probability matrices change based on the context. For example, search engines are more inquiry-based, while messaging apps are more conversation-based. While these start with predetermined values, they learn from user history over time. Predictive text relies on previously calculated probabilities that denote how likely a word is to follow the words you type. These probabilities are represented in stochastic matrices that store the info on particular words. Stochastic matrices that are dependent on previous forms are known as Markov chains. Here is a diagram of a Markov chain showing the ways that the probabilities for different values interact with one another, as well as a stochastic matrix that has been multiplied to produce the next iteration in a Markov chain.
Initial stochastic matrices for predictive text are usually formed using an initial data set. For example, we begin our set with three-word sentences. We start with I as our constant first word, and from there we can calculate the likelihood of each second and third word. If we start at I, there's a 33% chance that our second word will be like, and a 66% chance that our second word will be love. Moving forward, we can see that if our second word is like, there's a 100% chance that our third word will be T-Monk. If our second word is love, there's a 50% chance that our third word is algebra, or a 50% chance that our third word is interstellar. The three sentences given provide a very basic example. In real life, as more words and phrases are introduced into a system, the stochastic matrix will increase in size and cause a change in probability for each word, but also yield more complex sentence possibilities. Over time, the stochastic matrix and Markov chain used for predictive text will adapt to both user settings and system settings. For example, search engines such as Google will use location of the user to implement better search results, such as predicting the weather in a given area or giving stuff to do in a new location. Other users' searches can also influence predictive text. For example, popular topics will become more prevalent, such as recent game scores or current events. Finally, personal user information will also influence stochastic matrices and predictive text. For example, names of family members or friends, locations, and common times will become suggested information for messaging apps and social media. Predicted first and subsequent words and phrases are suggested in order of their frequency of use in descending order, with the highest probable next answer appearing first, preceded by the next likely answer.
Predictive text is an application of linear algebra that you encounter on a day-to-day basis, but were probably previously unaware of. Thankfully, our presentation has fixed that.